Hi, my name's Terry McCosker, and I'd like you to come with me as we walk through the process of measuring soil carbon with CarbonLink.
Measuring soil organic carbon. The old agricultural paradigm is that you go out with a soil corer mounted on the back of a ute and you squeeze that down into the soil, pull out a core, and then by hand break it up into sections, put those in plastic bags, send it off to a laboratory and wait a couple of months for some sort of results. If we're to do that on a large scale to measure soil carbon, it's going to be too expensive and probably too inaccurate for us to be able to do it. So over the last 12 months, during 2012 and 2013, CarbonLink, in association with CSIRO, did the first large-scale commercial accurate soil measurement in the world when we surveyed around about 8,000 acres. Out of that has come a process for accurately measuring soil carbon, and it's a 6-step process, and we'll go through those now one at a time. The first step is to look at aerial photography, get data from various sources, apply that to an individual property, look at what parts of the property are likely to be able to sequester carbon and the probability of the rate of sequestration, what needs to be excluded, what needs to be included, and what management needs to change. And from that, we could get an estimate for a particular property of what's it cost then to baseline that property and what are the likely financial outcomes. There's a number of ways in which that can be done. So this is an American instrument which really doesn't work too well on Australian soils. We're doing some work on looking at aerial mapping, but we've got a bit to go with that. Also can be done from the ground using a number of instruments, some of which you can see in the photographs on the screen. So the step is then to use various instruments to look at the variability on the property or in the paddocks in which we're measuring. And you can see occurring here a variation map. And on that map there are about 10 variants of soil type. We're not measuring carbon, we're simply measuring variation in the soil, which is the enemy of measuring soil carbon correctly. And those are called strata. So that's the stratification process. You'll see here the equipment that was used in the large-scale experiment in New South Wales in 2012. What that equipment does drove over the entire property on the right-hand side, and every little line you can see there is where it actually drove. Out of that comes a map of the variability, and in this particular area there's 72 strata. In other words, 72 variants in the soil down to a metre. It's then able to establish where we need to go to take soil cores, and you'll see the old agricultural paradigm on the right, which couldn't drill soils in this country because it was too hard by the time we got to do it, and so we needed some fairly heavy gear to be able to do that. A different unit here that's used in the United States for measuring soil cores. Once the cores are pulled out, they're no longer analysed in the old way in a laboratory. There are several techniques for measuring not only the carbon but the bulk density in the soil. The next step is to calculate the soil organic carbon over the area surveyed. So the first thing is to find all the data that we have in the stratification and in the soil cores and start crunching the numbers, and there's a lot of number crunching required here, so we need some pretty good computers to be able to do that. And finally we get some answers on soil organic carbon. And this is what that looks like for one particular core that we took on that experimental area. And you'll see this is recorded in every 5 centimetres of the soil profile. So we've got bulk density and carbon percent measured, and those come together to form tonnes of carbon per hectare. We're then able to work out where the carbon is and how much carbon is across that site. So here we've got the carbon spread across 3,500 hectares. The mean amount of carbon per hectare on that site was 55 tonnes, measured with an incredible accuracy of plus or minus 0.29 of a tonne per hectare. And that is amazing accuracy for soil carbon. During that process, that was compared to some other standard measures of soil carbon, and the stratification method using the sensors was around about 100 times more accurate than the most accurate of the standard techniques of doing it. The last step is then to calculate the carbon dioxide. So soil carbon is only one part of the equation. You've then got to take into account the number of animals, the fertiliser history, any via history, above ground woody biomass, and a whole range of issues that start to affect the actual carbon dioxide level. And the process is to use these 6 steps to establish what's called a baseline. And the baseline is your soil carbon and your carbon dioxide emission level at base. And the process then is to change practices, measure and record what that change of practice is, and then after about a 5-year period, come back and remeasure all of those things and determine what the actual carbon dioxide change is. In the next session, we're going to talk a little bit about how CarbonLink can actually assist you in this whole rather complex process.